Welcome back, everybody. And today what we're going to be looking at is the electron configuration. And essentially where in all of those orbitals that we talked about before, S's and P's and D's, where do the electrons actually exist? And are there ways for us to figure out exactly where all of the electrons are going to go? So that's some of our objectives today. We want to figure out what principles help us determine where the electrons are going to be, and then apply those principles to determine the location of all the electrons in an atom. So let's look at some of the rules for putting electrons in. Now, on the screen you're going to see this orbital diagram that I've created over here. This is going to be our guide for right now before I show you all the tricks and everything that help us determine them. This is going to be our guide to figure out where all of the electrons go. And there are going to be three rules that we're going to need to know to determine where the electrons are going to go in our orbitals. The first one is what we call the Aufbau principle. The Aufbau principle tells us that the electrons want to occupy the lowest energy level it can. What that really means is they fill from the bottom energy level up. They're really lazy. So I start down here in 1s. If we remember, this big one is our principal energy level. This is the closest one to the nucleus. This is lowest in energy. So it starts down here at energy level number 1. And then it's going to start to move to 2, 3, 4, 5. And I look and I see which one's going to be the lowest energy level. So I fill up 1 first, then I fill up 2s, 2p, 3s, 3d as I progressively get further and further and further away from the nucleus. That's our first rule. Our second rule is going to be the Pauli exclusion principle. That says that no two electrons can have in the same atom can have the same set of 4 quantum numbers. It's really confusing. So what we can say is that if I have to put 2 electrons in an orbital in one of these tiny little circles over here that I'm using to represent where the electrons go, they have to have a spin up and a spin down. And what we're going to use to represent electrons is going to be a half arrow. So if I have a half arrow that looks like this, that's going to equal 1 electron. And if I have to have them paired together, they have to be going up and they have to be going down. I can't put them together both facing in the same direction. That's our Pauli exclusion principle. And the last one that we're going to have is Hund's rule. That if I have orbitals that have equal energy, we're talking about ones that look like this, p's over here, here, and here, that I have to fill up every single one of them first before I put in a second one. So that means if I have to go to this p orbital over here, that I put in 1 electron here, I put in 1 electron here, and I would put in 1 electron here before I would come back and pair them and put them together. I can't do this. I can't come through and say that I want to put 1 here and 1 there if I have space for the other ones. That can't happen. I would have to go through and put them in each individual orbital first before I'd come back and put them together. Now we use all 3 of those rules to figure out all of the configurations for any particular element that we are looking at. Let's start to use the principles that we just talked about to determine the electron configurations for different elements. So the first one let's look at is oxygen. Let's look at oxygen over here, and then we'll look at argon. So the first thing we have to do when we're deciding the electron configurations for these elements is determining how many electrons they have. So oxygen is going to be neutral, so I can look at my periodic table, and I can see that the atomic number for oxygen is 8, so it's going to have 8 electrons. So let's use all of those rules that we just talked about, Aufbau principle, Hund's rule, the Pauli exclusion principle, to start to determine where all of these electrons are going to be. The first thing I want to tell you guys first is that we're going to represent electrons for this with this half arrow. When we start to do these, a half arrow equals an electron. If I have 2 half arrows, that's 2 electrons, 3 is 3 electrons, and so forth and so on. So I've given you a diagram here that's going to help us determine what orbitals the electrons go into and how they are going to be kind of existing around the nucleus of an oxygen atom. So Hund's rule tells us, or the Aufbau principle, I should say, tells us that we have to start at the lowest energy level, which is this one right here. And then we're going to move our way up once these orbitals are full. So I can fit 2 electrons in each orbital. So I can put 1 electron in, and then I can't put another one in there in the same direction. The Pauli exclusion principle tells us that I have to put it in the opposite direction. So I have 2 electrons in here because the goal is to get to 8 and distribute 8 electrons around there. So I've put 2 in the 1s orbital. Now I can move up because I don't have anything else here. There's nothing else over here in that 1s orbital for me to go through and fill up. Now I can move on to the second energy level. And the first one that I get here is the 2s. So I can put 1 electron in, and I can put another electron in. Now I can't move to the third energy level yet because I still have electron space over here in the 2p orbital. So I can't move up just yet until I fill up everything in the 2p. So I have 4 more electrons that I have to use. I can put 1 in here, I can put another one in here, and a third one over here. This is Hund's rule, that I need to fill up each and every single orbital in the 2p before I move on to putting them and pairing them together. Now that I've put them in there, I have 1 left over. So I can put 1 more down here. And if I count, I have 2 electrons over here, I have 2 electrons over here, and I have 4 electrons over there. And now I can start to put the configuration together. So if I want to get the configuration for oxygen, I'm just going to write the symbol. I can start to go through from the bottom and work my way up. So oxygen is going to have a configuration of 1s, and now we have to say how many electrons we have in there. And I have 2. And now I move on to the 2s. That's the next one that I filled in. 2s2, because I have 2 electrons in there. And then I move on to 2p. Then I'm going to count 1, 2, 3, 4 electrons. And that would be the configuration for oxygen, counting how many electrons I have and where they're going to end up. This is like the address for all of the electrons in your particular element. Now let's move on to argon. We're going to do the same thing. So I need to figure out how many electrons I have in argon. And now I'm just going to fill in my chart the same way that we did for oxygen. So I need to fill up 18 electrons. So I'll start here. That's 2, 1, 2. Now I can't move on to 3 until I fill up all of this second orbital. 1, 2, 3, 4, 5, and 6. Now if I just want to take a quick count here, I've used 2, 2, and 6 electrons. We're at 10 total electrons. We're not at the 18 that we want right now. So now I get to move on to the third energy level. And we're going to follow the same rules. So I go with 3s, and I fill it in. And now I move on to the 2p. And I'm going to fill it in until I get to 18. And if I count, I use 2 electrons there. I use 6 electrons there. And if I count up all the electrons, 2, 4, 10, 12, 18. So I've filled up all of my electrons in argon, and now I can get the configuration. And we're going to do it the same way that we did for oxygen. So I'm just going to start to slowly move up all of my orbitals and describe what's going on. So I'm in the 1s orbital, and I have 2 electrons. I'm in the 2s orbital, and I have 2 electrons. 2p, and I have 6. 3s, and I have 2. And the last one is 3p, and I have 6 electrons. This would be the electron configuration for argon. I know now where each electron is going to go, and I know what orbitals they're all going to be in. I know how far away they are based on their energy levels, and I know what orientations they're going to be in based on their orbital shapes. Let's use our principles again, the way we just practiced for oxygen and argon, to fill up a couple more elements that have more electrons. The first thing I want to do is get rid of this little ion part here. Let's just do a neutral calcium ion. We're going to use the same rules and the same ideas that we talked about with oxygen. So I'm going to start down here at the 1s orbital, and I'm going to work my way up in energy. So I fill in again. If I see a half arrow, that means that I have one electron, and I'm going to start to fill in that orbital until it's full. Each of these circles, again, can only fit in 2 electrons. And according to the Pauli exclusion principle, they have to be going in opposite directions. So I filled in the 1s orbital. I'm going to start to fill in the 2s orbital. And I want to go all the way up until I get to 20 electrons, because that's how many calcium is going to have. Right now I've used 2 here, and I've used 2 here. So we're not really anywhere close. So we need to keep going up our energy ladder. So I can fill in 2p. Once that's filled in, I can move up to 3s, 3p is going to get filled up completely. And if I start to take my count right now, I've got 2 here, I've got 2 there, 6 in my 2p, and I've got 8 in this whole energy level. I counted 3p and I counted 3s. So that gives me a total of 18 electrons so far, and we want to put in 2 more. Now once we get high enough in energy levels start to move around. So what I have to figure out is which one is the lowest energy level, because that's what's going to get the electrons first. And if I draw a line right down here, we're going to see that the p, or the 4s orbital right here, is lower in energy than the p orbital, because it's not at my line, and it's lower in energy than my 3d. So the s orbital here, 4s, is going to get those 2 electrons. And now I want the configuration, so I'm going to do the same thing we did before. So if I want the configuration for calcium, I'm just going to start down here at 1s. And how many electrons I have. I'm going to move on to 2s. And how many electrons I have. 2p and the electrons. 3s, the electrons. 3p. And now I've introduced a new energy level, 4s, and all of my electrons. Same thing can be done for arsenic. So arsenic's going to end up having 33 electrons. We're going to do it the same way we did everything else. So I'll start down here at 1s, and I will start to fill in, move that over for you, and I'll start to fill in all of my orbitals with 2 electrons as I go. Starting and filling in from the lowest energy level, and making sure that as I fill them in, if I have to pair them up, that they get filled up and paired together in opposite directions, and that everything gets an orbital first. Everything gets an electron first before I pair it together. So now I've gotten to the point where I have multiple orbitals at the same energy level. I fill up the 4s first because it's the lower energy level. And now if I look at this little line, if I look at here, we're going to find that 3D is lower in energy than 4P. So according to the Aufbau principle, that's the one that has to get filled up first. So I have to see how many electrons I have used so far. And right now I've used 20. So I can go through and say that my 3D can be filled up. I can fit 2 in each orbital. So I've used 2, I've used 8, 8, I've used 2 over here. And now in my 3d orbital, I've got 2, 4, 6, 8, 10. And if I add them all together, I've got 30 used. So I need to find a spot for 3 more electrons. And I can't move on to the 5th energy level because I still have some space right here. Let's put those 3 electrons in. 1, 2, and 3. If I want to get the configuration now for arsenic, I'm going to do the same thing we've done. I'm going to do 1s, and how many electrons? 2s. How many electrons? 2p, 3s, 3p, 4s, and now I filled up my 3d orbital first, so that's what's going to get drawn in next, and I put 10 in there. Then I ran out of space, but the next part here would be 4p, would be 4p, and I used 3 electrons. So this would be the configuration for arsenic, where I have all of my electrons spread out into their orbitals. Let's recap the 3 rules that we just talked about. So we're going to have the Aufbau principle that tells us that we have to fill up from the bottom energy level first and then move our way up. We're going to have the Pauli exclusion principle that tells us that when I have 2 electrons paired together, they have to be going up and they have to be going down. And then Hund's rule that if I do have to pair them together, that each orbital gets an electron first before I go back and pair them up. I'll see everybody in class.